Follow me on 27, okay? Make sure you follow me. Experimental probability, it's based on trials, experiments, or surveys. It's what like actually happened. Can we write that down? Actual events that have been recorded. So either they went around and asked farmers, hey, what are you planting this season, right? Or they asked, I walk around and I'm like, how many of you like Gatorade, right? I walk around and I keep track of that. Or what energy drink or what Powerade or whatever, what do you like the most? And I keep track of that. It's based on actual recorded events. So we still treat it the same way. It's favorable outcomes, but it's the number of trials that we're looking at. Okay? I'm going to use a different color for the other side. Theoretical probability is what most of you are used to. That is what you're used to. Okay? It is based on the possible number of outcomes. So it's the number of possible outcomes. That's what you've been dealing with this whole time. Okay? This is what should happen. Okay? I will say one even further. At the bottom of this box, use this used to make predictions. A few exclamation marks, just a few, just to drive the point home. So, for example, what's the probability of the coin landing on heads? What is the probability? 1 out of 2, right? 1 out of 2. However, let's say I flip it 5 times. Keep track, okay? Heads. So, heads. 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 Oh, the probability of it landing on heads is 100%, Mr. Dirksen. Look, it's not true. This is what the experiment did, right? The experiment that we performed, which is very small, okay? It's not true. So we always base it on the theoretical probability. The theoretical probability in this case is it's 1 out of 2. So I will give you that example down here. Example. A coin landing on heads 5 times out of 10 tosses. You can't see that, right? A coin landing on heads 5 times out of 10. No, sorry. 5 times out of 5. My bad. Get your act together. 5 times out of 5. The experimental probability would be what? 5 out of 5. It's 100%. But the theoretical probability would be what? 1 out of 2. You always go back to what did you use to perform this experiment? What were you using? You were using a coin. There are 2 options, and only one of them is your favorable outcomes. So the theoretical probability is 50%. So they can be different sometimes. But if you were to flip this coin 1,000 times, you would get pretty much the same answer. They'd be very, very similar. Okay, so in the long run, they should be the same. So this is a big concept here as well. Small sample space, right? If there's a small sample space, the experimental will probably be nowhere near or way off your theoretical probability. But if you have a large sample size, sample space, the experimental is approximately what the theoretical probability is stating. Okay? And another box here I want you to highlight. When making a prediction, we use theoretical probability. Don't be using your experiment. Your experiment is most likely off. So use the theoretical probability, okay? 28. Here's where I actually want to get down to the example. And then you can work on this or any pages that you're still missing. Let's go to 28. Oh, are you still copying? You good? Okay, so here's the example. I hope you understand this part, okay? So if whatever I just did was like, what is that? Just follow this part. A bag contains various letter tiles as seen below. So this is your bag, okay? Here are the results. You were drawing, right? You draw a tile, record the results, you place it back in the bag, and then repeat that process 8 times. Let's write this down. 8 trials. You performed 8 trials. And this is what you got. You recorded it. State the experimental probability of drawing the letter A. You're going to put down 8 trials. You drew 8 tiles. And how many of them are A's? 1, 2, 3, correct? 3 times it happened. So you're going to go 3 A's out of 8 trials. So your probability is 3/8, and that actually turns into a decimal, right? Let's write the decimal, 0.375. It's a finite decimal, so why not write all the decimals down? Now, state the theoretical probability. So here's the difference, right? This one asks for experimental. You base it on the trials. You can draw an arrow to it, okay? I used what actually happened to come up with the experimental probability. You can think of it as an experiment that you performed. Theoretical probability, on the other hand, we're going to go, what did you use to perform your experiment? What did you use? You used this bag to actually make your trials, to come up with your results. So, in theory, how many tiles are there in this bag? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 tiles. And how many A's do we have? 1, 2, 3. There are 3 A's in the bag. That would be 3/10. What does that turn into as a decimal? 0.3 exactly. Let's go 30%, right? This is 30%. This other one here was 37.5%. So they're off. What's going on here? Why are they off? Why is the experimental probability different than the theoretical probability? Explain. In general, write this down. In general, theoretical probability should be similar to the experimental probability. In this case, they are not, comma, due to a small number of trials. That is the main reason here. If you just ask very few people, what is your favorite pizza topping? If I just ask 4 people and they all say pepperoni, and then I say 100% of people like pepperoni, it's too small of a sample size. You need to ask maybe a couple hundred people or thousands of people, and then you're going to get an accurate answer. So this is the reason. This is the reason why the answers are off. What should be done to remedy this, to fix this? To fix this, Alex should increase the number of trials. That's all we're going to say. We're not going to speculate, oh, once he does 1,000, then they're going to be the same, or once he does 10,000. You just need to know, increase it. Okay? I'm going to highlight that as well, though. Increase the number of trials. That's how you fix it. If it asks you what should be done about it, increase the number of trials. If it's a spinner, spin more. If it's flipping a coin, flip more coins. Right? Keep doing it, and then the theoretical and the experimental should be the same. So let's keep going. If Alex would draw 500 tiles, how many would you expect to draw the letter A? How many times? You're making a prediction. We're going to go probability of grabbing an A times 500. Which probability will you pick? Christian, can I pick on you? Which of the 2 probabilities to make your prediction? Because we've done that already. We know the probability of A. Am I going to use the experimental or the theoretical? Jesus, do you know? The theoretical. The theoretical always wins. Okay? So we're going to use 3 over 10 times 500. I will make a note here. Theoretical. Use theoretical probability. Let's put it this way. If you go gambling, you're at a casino, at a poker table, you shouldn't be gambling, but let's say you have fake money, okay, to lose. The probability of you drawing a red card is what? 26 out of 52. That is a theoretical probability, and that is what you would expect in the long run. It could be that on that particular evening, on that table, almost all cards are black that are drawn, right, or whatever, that are dealt. But in general, if you played 1,000 times, you would expect about half and half. Half time you get a red one, half the time you get a black one. So we use the theoretical probability. Okay? What is this? 3 divided by 10 times 500 is 150 times. If you use the experimental, you would get 187 times, which is off. Okay? State the experimental probability of drawing the letter B. Let's do that. How many experiments were performed? 8 trials, so we've got to use the number 8 down here. And how many B's did we get under the trial here? Let's go up. We've got only one B. That's all we got in our trial. So this is an experimental probability, right? So it's 1 B over 8 trials. So it's 1 over 8. At 0.125. State the odds as well. It wants the odds in favor of as well. We'll just go 1, 2, 1 to what? If it's 1 over 8 is the probability, then it'll be 1 to 7 would be my odds of that happening. What's the theoretical probability of drawing the letter B? Theoretical. You don't care about what actually happened. You're going to go to the bag. Let's go to the bag. How many B's are there? 1 and 2. There's 2 B's in that bag of 10. So you're going to go over here and say 2 over 10, which is 0.2. Say, okay, we're off, right? State the odds against as well. Odds against a letter B, that means that we want the B's here and all the letters that are not B's up front, okay, against B. So we know that there are 2 B's, and therefore there are 8 non-B's. Okay? Fun stuff, eh? I know. I'm going to ask you to try 29. It goes all the way to 30 to 35. We're going to say 35 now. I'll do one more. Please make corrections or follow along as needed, okay? In this case, guys, the theoretical probability of the coin landing on tails, okay, what would that be in theory? You actually got to go back to the coin. That is basically like your bag of tiles in the previous question, right? In this case, what was used to perform the experiment? It was the coin. You have 2 options for it to land, right? In theory, it's only 1 or 2 options. That's it. 0.5, 50%. That's it. If it says experimental, right, you want to base it on the actual trials. Like you want to actually consider what happened. Okay? Base it on recorded events, if you want to call it that way. Base it on recorded events. How many times was this experiment performed? How many times was the coin flipped, guys? 160 plus 240. So it's 160 plus 240. And how many times of those times it landed on tails? 240 times. So that's what goes on top. So this ends up being 240 over 400. You can leave it like that, you can reduce it, you can do whatever you want. But this is what I'm after when it comes to experimental versus theoretical. One more. Just wait for one of them to come back. Christian. Sure. Yeah. What about this one? If you toss the coin 1,000 times, how many times would you expect it to land on tails? This is a prediction. Let me ask you again, which probability are you going to use out of the 2 here to make a prediction? Theoretical. You always use theoretical. So we're going to go theoretical probability times 1,000. The theoretical is half. What's half of 1,000? I think you guys can know that one. It's 500 times you're expecting it to land. So the only time, guys, listen to this one, because you're gonna tell me, you told me it's theoretical every single time. The only time that is not the case is if all you have is the experimental. So for example, blood type, there are, what, 6 or 7 types? I'm off. Maybe, let's say there's 6. I might be off. Don't quote me on that. Is it true that it's 1 out of 6 chances that you have a certain blood type? Is that true? That they're all equally distributed? No. There's actually a certain blood type that is way more prevalent than any other. So when it comes to blood type, we can't go, oh, there's a 1 in 6 chance that you are Rh positive, right? Can't say that. So there's certain instances where theoretical probability just doesn't work, okay? So, but for the most part, when you have the choice, use theoretical probability.